This is the stats review problem, page 136. It's a review for part 1, and it is problem number 25, the one about avoiding an accident when driving can depend on reaction time. And it says that time measured from the moment the driver first sees the danger until he or she sets foot on the brake pedal is thought to follow a normal model with a mean of 1.5 seconds and a standard deviation of 0.18 seconds. We have several things that we're supposed to do with this problem. So the first thing we're supposed to do is we're supposed to draw a normal model. So let's try and do that on this tablet. Here's our normal model curve. And I know I have my mean right here at 1.5. And then I'm going to have several standard deviations. 1, 2, 3 that way. And I'll have 1, 2, 3 that way. And I'm going to label those. This is 0.96. This is 1.14. This is 1.32. Way over here is 1.68. Then 1.86. And finally 2.04. Each 0.18 standard deviation away from the rest. So that's kind of what our model looks like, and we know that we have 68% between here and here, and 95% between here, and 99.7% between here and there. So part C of this problem says what percent of drivers have a reaction time less than 1.25 seconds. So 1.25 seconds is going to fall somewhere in here, and I want to find out what percentage of them have a reaction time less than 1.25 seconds, which, as you might see here, is a good thing, because the faster your reaction time, the better you are, but we always have our lower values to the left and our higher values over to the right. So if I want to find out what percentage that is, the first thing I need to do, well, if I'm going to find a percentage, I need to have, to find a percentage, I'm going to use my normal CDF function, and I have to have two arguments. I have to have a z that's a left argument, and I have to have a z that is a right argument. So I'm going to have a line on the left, and I have to have a z-score on the left, and I'm going to have a z-score on the right. Well, let's see what the right one's going to be, because what I know about this particular line is that it is it represents 1.25 seconds. Well, let's go to our formula. Z is equal to y minus mu over standard deviation. What can I fill in here? Well, I don't know my z yet, but I know the z is equal to my y. I know that the y is my 1.25 because that's my actual value, 1.25. I know my mean is 1.50, and I know my standard deviation, this is again from our normal model up here, is 0.18. Let's call up our calculator and see what we can do with it. Well, let's clear off my screen. I'm going to clear off my screen. And so by doing a little bit of cross multiplication here, actually, before I get to the calculator, I can multiply both sides of my equation by let me get a pen. And I multiply this by 0.18, and I'm going to multiply this by 0.18. So I'm going to have 0.18z is equal to 1.25 minus 1.50 is negative 0.25. That means that I'm going to divide this side by 0.18, and now I'm going to divide this side by 0.18. So I'm going to get my z is equal to, let's go over to the calculator, I'm going to put negative 0.25 divided by 0.18 is equal to negative gotta make it a negative 1.388. Little bar there indicating the 8's go on forever. That's my z-score at this point here. I'm going to write that in here as negative 1.388. So now I need to find the percentage underneath my curve from this line here, this z-score of negative 1.388, all the way out as far as I can go to the left. Well, my farthest z-score that I can have on a normal curve, and that fits into the calculator, that's when I use my negative 99 z-score, because I want to go 99 all the way over into the cafeteria z-scores to the left. So going back to my calculator, I'm going to go second vars. I'm going to pick number 2 for normal CDF, and I'm going to fill in two numbers. I'm going to fill in negative 99, my z left value, and I'm going to put my comma, and then I'm going to fill in negative 1.388. That's my z right value. I'm going to put it in my parentheses. I'm going to press enter, and that's going to give me my percentage. So the answer to this part of the problem is, well, 0.0826, and I multiply that by 100 to give me 8.26%. And that's the answer to this first part of the problem, section part number C. Let's go now to part number D. That's where they are asking what percent of drivers have a reaction time less than 1.25 seconds. No, I'm sorry, that's C. They're asking what percent of drivers have reaction times between 1.6 seconds, which is somewhere around here, so we'll call that 1.6 seconds, and 1.8 seconds, which looks like it would be somewhere around here, 1.8 seconds. So again, I'm trying to find a percentage between two values on my curve. If I'm trying to find a percentage, I have to have normal CDF, left z, and right z. So I'm trying to find the percentage, so I need a z-score for 1.6 and a z-score for 1.8. Well, z is equal to y minus mu over standard deviation. So let's first do it for 1.6. 1.6 minus 1.5 divided by 0.18. That is equal to, let's get the calculator up, clear that off. Well, 1.6 minus 1.5 is 0.1, and I'm going to divide that by 0.18. So that gives me a z-score of z-score of 0.555, and a bar there that's going on forever. So this z-score right here for my 1.6, I'm going to write it right above here. I'm going to go 0.555. Let's do the z-score for 1.8. Well, it's going to be 1.8 minus 1.5 divided by 0.18. Back to the calculator. 1.8 minus 1.5, which is going to give us 0.3. And I'm going to divide that by 0.18. That's going to give me a z-score of 1.66. So the z-score equals 1.666. I'll write that up here. 1.666. And you can see that with our picture, that kind of makes some sense. I know that this first line here is less than 1 standard deviation. 1 standard deviation would be 1.68. So it's clear that my z-score will be less than 1 but greater than 0, which is our mean. So that's the 0.55. And our next z-score that we're looking for is between 1 standard deviation and 2 standard deviations, so 1.666. That makes a lot of sense too. So what I'm trying to find now is I'm trying to find the area underneath this curve here. That's going to give me the percentage of total values that are between these two z-scores. And for that, I'm going to again go to our normal CDF function. So let's plug that in, see what that looks like. Second vars, 2 for normal CDF, and my left is 0.555, comma, and my right is 1.666, close the parentheses, enter, 24.16%. Well, it actually goes 0.2416 times 100 is equal to 24.16%. And that's the answer for this part of the question, D. And just notice here again that we're finding the area under the curve. We're finding the percentage of values underneath the curve. To find the percentage of values, we just need two z-scores, a left z-score and a right z-score.